Hello, this is the luckiest maths teacher in the world. Thanks so much for tuning into this short video. I just wanted to make sure you understand what it means for an ordered pair to be a solution to a set of simultaneous equations. So let's look at a pair of simultaneous equations. So on your screen, we have two equations in blue. Now, each of them has infinitely many solutions. Let's start with this one here, y equals 2x plus 1. So a solution is an ordered pair, a set of x and y values. So for example, the ordered pair 1, 3 is a solution to this equation, because if you substitute x equals 1 and y equals 3 into this equation, you get a true statement. So similarly, a solution to this would be minus 2 minus 3. If you substitute x for minus 2 and y for minus 3, that makes this a true statement. So it's an ordered pair. We always have the x value first and the y value second. In fact, this equation here has infinitely many solutions. So what we often do is, rather than writing infinitely many solutions, we plot this on the Cartesian plane. So we can plot each of the solutions to this equation y equals 2x plus 1. So 1, 3, we could plot as this point here, minus 2 minus 3 would be this point down here, and there are infinitely many more. 3, 7 is a solution to this, as is 2, 5. It turns out that all of these lie in a straight line. So for the second equation, x plus y equals 10, it turns out it has infinitely many solutions as well. We could have x equals 10, y equals 0. We could have x equals 0, y equals 10. We could have x equals 3, y equals 7, and so on. So we can also plot these as points in the Cartesian plane. So 10, 0, x equals 10, y equals 0 would be there. It also goes through 3, 7. Another solution is x equals 4, y equals 6, which would be there. Again, all of its solutions lie in a straight line. So what we have are two equations here and here. This one has infinitely many solutions. This one has infinitely many solutions. Their graphs are just the set of all of those infinitely many solutions. So the solutions to this equation are all the points that lie along this line. The solutions to this equation are all the points that lie on this line. So when we have a simultaneous solution, we want a solution that solves both equations at the same time. And that's this point here where they intersect 3, 7. So the simultaneous solution here is x equals 3, y equals 7. Because if I substitute x equals 3, y equals 7 into this equation, it makes it true. If I substitute here, it makes it true. This is a solution to this equation, and at the same time, a solution to that equation. All right, thanks so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.